Assalamualaikum and good day to all. Now we are going to talk about relative velocity. Okay, so when we talk about relative velocity, we are going to find a velocity of an object with respect to a certain reference frame, or we can actually say that how observation made in different frame of reference. Okay, so example, in front of you, you can see that there's a person walking inside the moving train. Example, me, okay, I'm going to be at the ground. I'm going to see this person walking inside the moving train. So what is the velocity of this person with respect to me at the ground? Okay, so frame of reference can be at the ground, it can be at the shore, it can be in the air. So it depends on the question and depends on the situation. Okay. Okay, so when we talk about relative velocity, we are going to talk about vector. Okay, so means that you need to consider the direction, right, left, up and down. Okay, but example, if the object moving in the same direction, which you can see in front of you, okay, moving, like example, both moving in x component or both moving in y component, you can just use plus and minus to solve the problem. But example, if you have one object moving in x, one object moving in y, then you need to use Pythagoras theorem. Okay, before we start our calculations, definitely you need to understand and you need to know how to write the equation of relative velocity. Okay, so example, okay, if the question state, please find the velocity of ball with respect to ground. Okay, example, if the question asks you to find the velocity of ball with respect to ground. Okay, please take note, the first one going to be the object that you observe. Okay, the object that you observe, and the second subscript going to be the observer, which means that this observer located at the ground. Okay, so the equation is going to be VBG equals to the first subscript you're going to put at the first part, and the second subscript you are going to put at the second part, second equation at the second subscript. Okay, so here we are going to put another subscript, and it depends on the questions. Example, in the question they state trolley, or state any locations, like example in the air, in the water, something like that, then you need to put that. So example here, the question state about water, so maybe you can actually put water and water here. So what happened is at the middle is going to be cancelled out, then you are going to get back the original physical quantity. Okay, so this is basically the way that you write the equations. Okay, so example, if the questions didn't state any location, like example, you can see that in front of you, you have 2 meters per second and you have 3 meters per second, and this question doesn't state what is the location of the observer going to be. So for this one, mostly the velocity going to be with respect to ground, or you can actually say earth. You can actually use ground or earth. So it means that, okay, so it means that example, at the ground, okay, there's a person at the ground watching the observer, the first one, moving with 2 meters per second, and watching these children moving with 3 meters per second. So what happened here is, if the question didn't state any locations, then you are going to put at the ground or earth. Okay, because the ground and earth going to be your main reference frame. Okay, because everyone actually moving at the same planet, which is earth. That's the reason why we are going to use our main reference frame going to be ground or earth. Okay, so now the questions ask you to find what is the velocity of the observer with respect, what is the velocity of the children with respect to the observer. Okay, so means that the question asks you to find, what is the velocity of the children, okay, the children with respect to the observer. So the observer see these children moving to him with what velocity? Okay, so for this kind of questions, the first thing that you need to do is you need to come up with the equations. Okay, so the question asks you to find what is the velocity of the observer. So observer, I'm going to put it as a q, and I'm sorry, what is the velocity of the person that you observe, which is p, with respect to q. So q is the one that observe the velocity of p. Okay, so it's going to be vpq v plus v and q. Okay, so this one we are going to put ground and ground. Okay, like I mentioned before, if example the question doesn't state with respect to, so means that both basically moving with respect to ground. So this one vp, this one I'm going to put it as a vp with respect to ground, which is 3 meter per second, and this one going to be vq ground, which is 2 meter per second. Okay, so vpg, which means that vpg stand for v, the person of p with respect to ground, which is going to be what? Which is going to be 3 meter per second. Okay, so it's moving to the right, so you are going to put positive 3 meter per second. Okay, in the equations they give you v ground q. Okay, which means that velocity of ground with respect to q. However, from the equation itself, you can actually see that the information given is velocity of q with respect to ground. So basically what happened here is, based on vector, when you have v gq, if you want to have vqg, then it's going to be in the opposite. So it means that you are going to put negative over there, which means that this one going to be negative vqg. Okay, same magnitude, different direction. Okay, so now the question state positive vgq. So right now the information given is vqg. Therefore, we are going to put negative over there to represent opposite, because the subscript already changed. Okay, and then it's moving to the right, therefore it's going to be plus 2 meter per second. So you are going to get answer is 1 meter per second moving to the right. Okay, because it's vector, then you need to state the direction. Okay, let's try with another question. Okay, so as you can see that we need to find the velocity of ball relative to A, B, and C, and the situations of the person that observe going to be different, where the person A basically just sitting there. Okay, this person A is sitting there, and the person B are running towards the ball with 5 meter per second, and for the person C running towards the ball with 5 meter per second, but basically running on the moving trolley. So we need to find the velocity of the ball relative to A, B, and C. Okay, so first thing first, when you have this kind of thing, you need to find the okay, for example, right now we need to find this one first, which is the velocity of the ball relative to ground. The questions give it to you the velocity of the ball relative to car, which is 10 meter per second. It means that there's a person inside the moving car, throw the ball with 10 meter per second, and the car actually moving with 20 meter per second. So what is the velocity of the ball relative to ground? So it's going to be a different value. So we need to find that first. Okay, so I'm going to put it as a velocity of the ball relative to ground. Okay, so velocity of the ball. Okay, so right now the object there is going to be a moving car plus velocity of the car relative to ground. Okay, so velocity of the ball relative to car going to be 10 meter per second, which is moving to the right. Okay, and velocity of the car relative to the ground going to be 20 meter per second. Like I mentioned before, if the question didn't state anything any location or reference frame, then it means that the car is moving 20 meter per second with respect to ground. Okay, so you are going to have that moving also to the right plus 20 meter per second. So you are going to get the velocity of the ball relative to ground going to be 30 meter per second to the right. Okay, so we are going to solve question of the first one, which is velocity of the ball relative to A. So remember, before you start, come up with the equation first. Okay, so the question asks you to find velocity of the ball relative to A. Therefore, the equation going to be velocity of the ball relative to A. So it's going to be velocity of the ball relative to ground, because the object over there is only ground, and the velocity of the ground relative to A. Okay, please take note, the first going to be the first one subscript, the second one going to put at the second part and the second subscript. Okay, that's how we do it. Okay, so velocity of the ball relative to ground, we already find it, which is 30 meter per second, moving to the right. Okay, and inside the equations, they give it to you VGA, which is velocity of the ground with respect to A. However, the person there doesn't move, so you can actually just put it as a 0. Okay, but here it should be -0. Okay, why is become negative? Because this person, okay, is the velocity of person A relative to ground. Okay, but the equations state VGA, so therefore it's going to be negative VGA, but the person doesn't move, then you just put it as a 0. So you are going to get answer is positive 30 meter per second moving to the right. Okay, so next is velocity of the ball relative to B. So I'm going to use I'm going to put the ball as VBL and the person is B. Okay, just to make sure that you didn't confuse. Okay, so velocity of the ball respect to B, so it means that velocity of the ball with respect to ground, okay, plus velocity of the ball velocity of the ground the ground respect to B. Okay, so velocity of the ball with respect to ground, we basically already find it using this formula. Okay, so we are going to get positive 30 meter per second. Okay, however, for this one, this person, it's moving with 5 meter per second to the left, which means that now the 5 meter per second denoted as velocity of the person B relative to ground. However, in your equations, they state velocity of ground with respect to person B. Therefore, we need to, make it opposite direction, which means that velocity of the ball with respect to ground equivalent to negative velocity of the ground with respect to person B. Okay, so you're going to put negative there to represent the change of the subscript there. Okay, so means that it's going to be negative. Okay, it's moving to the left, right? So you need to put another negative because it's moving to the left 5 meter per second. Okay, please take note, the negative here to represent VBG equals to negative VGB. Okay, because the subscript already changed the position. Okay, and then the negative here to represent the directions of the person B that actually moving to the left. Okay, so you are going to get the answer going to be positive 35 meter per second moving to the right. Okay, so it's logic because you run, okay, the person B running towards the ball, so the person B going to see the ball faster than the person A. Okay, so now we are going to solve the equation for velocity of the ball related to C. Okay, as I mentioned before, make sure that you find first the velocity of the person relative to the ground. So right now we have this person. Okay, we have this one person, they're actually moving to the left, and this person runnings runnings on the trolley that they're actually moving to the right, 10 meter per second. So what you are going to do is we are going to find the velocity of the person C with respect to ground first. Okay, so how to do that? Okay, we come up with the equation first. Velocity of the person C relative to ground will be equal to the velocity of the person C relative to trolley. Okay, because the person C runnings 5 meter per second on top of the trolley that actually moving to the right 10 meter per second. Okay, so going to be plus velocity of the trolley with respect to ground. Okay, so what happened here is velocity of the C with respect to trolley going to be to the left, which is negative 5 meter per second. Okay, and here the 10 meter per second represent velocity of trolley with respect to ground. Okay, so you are going to get that is plus, because you're moving to the right, so 10 meter per second. So the answer going to be 5 meter per second. So to the right. So someone at the ground see the person C moving 5 meter per second to the right. Yeah. Okay, so now we are going to solve for the velocity of the ball relative to C. So velocity of the ball relative to C, velocity of the ball relative to C going to be velocity of the ball relative to ground plus velocity of the ground relative to C. Okay, so velocity of the ball relative to ground going to be 30 meter per second. Okay, and then okay, the information that we get here is the velocity of the person C relative to ground, but in the equation is the velocity of the ground relative to C, so it's going to be, yes, we need to put minus there. Okay, and it's going 5 meter per second to the right, so you're going to get 25 meter per second to the right. Okay, so that's how you solve the problems were in the same direction, which is basically you can see that it's moving in only in x component. Okay, so let's try with another questions. Okay, so this question, state that a railroad flat car is traveling to the right at the speed of 13 meter per second relative to an observer that's standing on the ground. So we can actually say that the velocity is velocity of the railroad car relative to the ground, which is 13 meter per second to the right. Okay, someone is riding a motor scooter on the flat car. Okay, so the question asks you, what is the velocity of the motor scooter? So what is the velocity of the motor scooter relative to the flat car? So we can actually say that there's a person at the flat car watching this motor moving with what velocity. Okay, so you need to find this, and the information given is if velocity of the motor, if the velocity of the motor relative to the observer on the ground is A, B, and C. Okay, so this is going to be the velocity of the motor relative to the ground. Okay, so definitely the first step that we are going to do is we need to come up with the equations, the vector equations. So the question asks you to find the velocity of the motor relative to the flat car. So velocity of the motor relative to the flat car will be equal to the velocity of the motor relative to ground plus velocity of the ground relative to flat car. Okay, make sure at the middle is going to have the same subscript, okay, because we are going to cancel this thing up, so you're going to get the original one. Okay, so velocity of the motor relative to the ground going to be, the first one is 18 meter per second to the right. So you're going to put it positive 18 meter per second to the right. Okay, and the equations, velocity of the ground relative to flat car. However, the question state here is velocity, I can put it as a flat car. Velocity of the flat car relative to ground is 13 meter per second. Therefore, we are going to put it as a negative value to represent the subscript already changed. Okay, so negative there, so it's moving to the right, so it's going to be 13 meter per second. So you are going to get your answer is plus 5 meter per second to the right. Make sure that every time you give the direction because it's a vector. Okay, so for question B, okay, what is the velocity? Okay, so we are going to use the same equation, the same vector equation. Okay, VGF. Okay, so the question states that the velocity of the motor relative to the ground going to be 3 meter per second to the left. So 3 meter per second to the left, so you are going to put negative 3 meter per second because it's moving to the left. Okay, and then why is it going to put the minus is because, like I mentioned before, VGF equals to negative VFG. Okay, so negative 13 meter per second. Okay, so you are going to get here negative 16 meter per second, which means that the velocity of the motor relative to the flat car for question B is going to be negative 16 meter per second moving to the left. Okay, and the last one, C. Okay, the same equation that you are going to use, velocity of motor relative to the flat car equals to the velocity of the motor relative to ground plus velocity of the ground relative to flat car. So velocity of the motor relative to ground going to be 0. Okay, from the questions it states 0. Okay, and here we are going to put it as a negative. Okay, like I mentioned before, this one. Okay, so we are going to put the executive, and the value is going to be positive 13 meter per second. So you are going to get negative 13 meter per second moving to the left. Okay, easy, right? Okay, so it's much easy for the relative velocity. So it's much easier for you to understand the relative velocity based on calculation instead of the theory. Okay, that's why I encourage students to come up with the equation first, and then after that decide the directions. Okay, make sure the directions, if example is moving to the left, make sure you put negative if you assume left is negative, and if you assume right is positive, then you put right positive over there. And please take note with the change of the subscript. Okay, V ground flat car equivalent to negative V flat car ground. Okay. Okay, so let's proceed to the next question, to the next part, where we are going to talk about example if the object moving in two different components, which is one is moving to the X component, another one moving to the Y components. Okay, so basically the same thing. You need to come up with equations. Definitely you need to come up with the equation, but okay, as you can see that in front of you, you need to find the velocity of the boat relative to shore, which means that you are going to come up with the velocity of the boat relative to water plus velocity of water relative to shore. Okay, please take note, when you have an X component and Y component, you cannot use plus and minus. You need to use what? Pythagoras theorem. Okay, like I mentioned before in the vector where A, B, and C, so it's going to be A squared plus B squared, then you're going to get C squared. It's not you cannot use plus and minus. You need to use Pythagoras theorem to solve this question. Okay, so this one already mentioned before. Please take note, the first subscript going to be the object that you observe. The second one going to be the reference frame, or you can actually say that the locations of the observer going to be. Okay, so you can see that there's two situations there. There's a one boat hits directly, but basically being pushed to the other side because of the river current, and there's another situations where the boat hits directly without any problem. So the question means that the first thing when it comes to the components, when you have a situation like this, what you need to do is you need to draw. Okay, you need to draw, then you can actually and then you need to understand the situations where the boats hit directly without being pushed by the river current, or another situations where the boat heads directly and then pushed by the river current, so it means that you need to find how far downstream will the boat be then because of the river current. Okay, so let's start with the first question. Okay, so here you have a boat speed in still water, which is VBW 1.85 meter per second. If the boat is to travel directly, okay, so the situation of the question, the boat is to travel directly across a river whose current has speed, at what upstream angle must the boat be then? So when you see the words of upstream, it means that this boat takes some action where there's a river current that, example, is moved to the towards moving to the east, okay, and then the question state that the boats want to travel directly without being pushed by the river current. So what happen is you need to make some action where you are going to moving like this, therefore you can safely moving directly without being pushed by the river current. So means that this is the upstream angle that the question asks you to find. Okay, so means that you make some action, you moving towards northeast. Okay, so when the river current push you to the east, what happen is you are going to move directly to the north. Okay, so the river current here is going to be the VWS, which is water relative to shore, which is 1.2 meter per second. Okay, and then you need to make some action, so means that this is going to be your VBW 1.85 meter per second. Okay, so when you see upstream angle, it means that you need to take some action, which means that you are going to point to some angle to make sure that you can actually hit directly without any problem, which is being pushed by the river current. Okay, so now the equation is going to be, the question asks you to find what upstream angle here. So you can actually use sine or cos or tangent, depends on the question. So now I'm going to use sine theta, okay, because I already have the information in the opposite and I have information in the hypotenuse. So sine theta opposite over hypotenuse, which is opposite you going to be VWS and the hypotenuse going to be VBW. Okay, so you're going to get here is 1.2 divided by 1.85. Okay, sine tangent shift sine, you are going to get 1.20 divided by 1.85. So you are going to get the answer is 40.4 degree. Okay, that's the, okay, make sure that you draw it first, because the one that you denoted as a VBW, it can be in hypotenuse, it can be in the adjacent, it can be in the opposite. So read the question carefully and then carefully understand whether the situation is going to be boat travel directly without any problem, without being pushed by the river currents, or example, if you have a river current that moving to the east and then you basically moving straight to the north, what happen is you are going to be moving like this. Okay, so you have the first situation where you really want where the boat hits directly without being pushed, and second is you being pushed by the boat, so means that you are going to move with some angle over there, you are going to, or the current pulling the boat downstream. Okay, let's see the next questions and decide the situations of the question, and then we are going to draw. Okay, so the same boat now hits directly across the river whose current is still 1.20 meter per second. So the situation of the question is different from the previous one, where there's a boat hits directly and there's a river current push the boat downstream. Okay, so means that your path going to be like that. Okay, so now your 1.85 going to be at this part VBW, which is 1.85 meter per second, and the river current is 1.20 meter per second. Okay, so example, if the question doesn't state direction like north, east, south or west, you can draw any directions for the river current. Okay, but if the question state north, east, south, or west, then you need to draw based on the direction given. Okay, so the question asks you to find what is the velocity, magnitude, and direction of the boat relative to shore. Okay, relative to the shore. So the question asks you to find the velocity of the boat relative to shore, which means that velocity of the boat relative to water. Okay, and plus velocity of water relative to shore. So this one is velocity of water relative to shore, and this one is velocity of boat relative to water. Okay, but you cannot use plus and minus because both in different component. One is x, one in y component. Therefore, you need to use Pythagoras theorem. Okay, so the question asks you to find what is the velocity of the boat relative to shore, which is this one. So you can just use velocity of the boat relative to shore, which means that 1.20 square, okay, plus with 1.85 square, okay, square, and you square root everything. Okay, so you are going to get the answer is 2.21 meter per second. Okay, okay, so let's move to the next question. Okay, if the river is 110 meter wide, so definitely, okay, the river is 100 meter wide. Okay, so it's going to be like this, which is 110 meter wide, 110 meter wide. How long will it take to cross, and how far downstream will the boat be then? Okay, please take note, the only physical quantity that you can use for x component and y component going to be time. Okay, because time for y component and x component will be the same. Okay, so 1 second you moving towards x, 1 second you moving towards y. Okay, 2 seconds moving towards x, 2 seconds moving towards y, and that's the reason you can use time. Okay, but the information given going to be 110 meter wide. Okay, please take note, information in y only for y, information in s only for s, and that's the reason why you are going to use 110 with the velocity of 1.85, because both in y component. Okay, so based on the basic so we are going to use the basic formula, which is velocity equivalent to x over t, or you can actually use y over t. So this one we are going to use y over t. So the question asks you to find the velocity, so time going to be y over v. So y is 110 and velocity is 1.85. So the answer is going to be 59.5 seconds. Okay, 59.5 seconds. Okay, so means that how long for the boat to cross is 59.5 seconds towards this direction. Okay, and then how far downstream? When the question state downstream, it means that it represent river current. Okay, when the question state downstream, it represent river current. So now the question asks you to find how far downstream. So means that we are going to use velocity of 1.20 meter per second, and we are going to use the same formula, which is v equals to s over t. The velocity going to be 1.20, and the s we didn't know. Time is 59.5. So you are going to get your s is 71.4 meter. Okay, okay. Okay, so this one doesn't need like a complicated formula. You only use a basic maths for you to solve the equations, but please make sure that you come up with the equation first. The reason why is because maybe you need to change the directions of the arrow. Okay, maybe you need to make it opposite. Okay, like the question after this. Okay. Okay, so here we have two automobiles approach a street corner at right angle to each other with the same speed of 40 km per hour, which is equivalent to 11.1. What is the relative velocity of one car with respect to the other? Okay, so basically the question asks you to determine the velocity of car 1 as seen by car 2. Okay, so come up with the equation first. Okay, you have velocity of car 1 with respect to 2, which means that velocity of car 1 with respect to ground plus velocity of ground with respect to 2. Okay. 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 Okay, so now, okay, so the information given here is the velocity of 2 with respect to ground, and this one is the velocity of 1 with respect to ground. Okay, so now it means that, okay, the equation give you v2g, but the equation here is going to be vg2. So you need to make it opposite direction. So the directions of your drawing going to be different. Okay, the first one, the car is moving like this. This is the v2g. Okay, and then there's another car moving like this, which is then the first car, v1g. Okay, because of this one, okay, then you need to make it opposite directions, because it's going to be minus over there. So when it comes to the minus, the arrow going to be pointed in the opposite directions. Therefore you are going to get v1g vg2 here, which is negative. Okay, and then there's a cars over there, v1g, so means that the relative velocity, the resultant going to be in this direction. This is the one that you need to find, v12. Okay, so make sure that you draw, because sometimes the drawing can give you marks. Plus it's going to help you especially to decide the direction. Okay, so please make sure that before you start your calculation, you come up with the equation first, and then you draw, and then you start your calculation. Okay, so now the question asks you to find the velocity. So because it's because both in the opposite direction, which is one is x, one is y, then we are going to use Pythagoras theorem. Okay, so the velocity 1 2 that you need to find is going to be 11.1 square plus 11.1 square. Okay, so it means that you are going to get 11.1 square plus 11.1 square, square root everything, you're going to get 15.7 meter per second. Okay, that's how you solve for the two-dimensional relative velocity. Okay, so the last question is going to be, there's an airplane fly due south. Okay, this question give you state the direction, so you need to draw based on the direction given. Okay, fly due south. Okay, fly due south. Okay, relative to the air, there's a wind blowing at 85 km/h to the east relative to the ground. What are the plane's speed and the direction relative to the ground? So basically what happened here is the plane going to be pushed by the wind. So your wind going to be in this direction, therefore the true path, the real path going to be in this direction. So this one going to be 175 km/h, and this one going to be 85 km/h. So the question asks you to find the plane speed, which is this one. Okay, and direction relative to the ground. Okay, plane relative to the ground, which means that velocity of the plane relative to wind plus velocity of the wind relative to ground. Okay, but because both moving both in the different direction, which is one is x, one in y, then you need to use Pythagoras theorem like this, and then you find the angle, which is angle this one. I encourage students to find the angle this one, but if you find with respect to the horizontal, it's okay, still we accept the answer. Okay, so that's all for now. So if you have any question, feel free to ask. Okay, so thank you very much, and assalamualaikum. Bye bye.